in the last two videos, we have explored kinetic and potential energy. But there was one big key skill missing from my videos, and that was your interaction. Because you weren't given the opportunity to take any notes besides the 2 to 3 bullet points on each slide I had. So this video should fix that. Now, it is a proven method that searching for the answers in an article is a lot more efficient for your mind. And it's like you learn more because of that. So, what we're going to do is fill out this worksheet. Now, so I'm going to have the article linked in the description below so you can read it, and I'm going to have the worksheet linked as well. I would suggest that you do the worksheet and then come back because I'm going to be giving out the answers here, but also explaining a bit. So, I'm not going to read the article on screen. You can read it on your own. If I went ahead to read the article, it will take a very long time. Alright, so read the article on your own time, and then come back for the answers. So the first thing is, what is the definition of energy? Well, apparently right here, energy is the capacity of doing work. This is terrible highlighting, but still. So energy is the capacity of doing work. So if I come here, and I open up the markup tools, to here, alright. So energy is the capacity of doing work. And I obviously spell things wrong. Alright. So energy is the capacity of doing work. Now, by me repeating this and you just listening to it, if you're an auditory listener, probably this will be very efficient for you. So that's why I am speaking the answers. So now, in here we have to explain with our own words, alright? So, like, explaining with your own words isn't that difficult. Like, I don't think you should have an issue with that. But explain with your own words will display if you actually know the topic. Like, if you can explain with your own words, then I don't see a reason why you can't answer any of the questions. Alright, so let's look for potential energy here. So, potential energy is very easy to identify. Potential energy, so I've highlighted that. So this is the definition. As any object, then it will contain potential energy. So that's basically the definition. So instead, we'll just say with our one word, we'll say any object with a height above ground level. Ground/surface. Alright. Look, so you want to make these notes to what you best learn with. So if you if you best learn in notes, you should always use your own words, because for one reason, and that is by using your own words, it's like it's written in your own language. Like, this article may for some of you be very difficult to read, and for some of you very easy to read. But the problem with informational text is that it's not written in a way that you can understand in one reading. Like, you may understand it, but you might have to go back for some. Now, obviously this article is written by me, and I'm no professional writer, so this is a little easier for many of you, but still, any informational text is going to be hard to read. So next time you have an informational text, which we will be having a lot more in this course, just break it down. I will be teaching some very cool strategies that you can use to just break down text. Alright, so if you're using Apple Markup, you can just click on your text and then left align it. It's pretty cool. Now, the reason I am doing this on digital is not just for the presentation, but being efficient for the environment, as we have to save trees because we don't want to waste paper. Now, something like an article, like, you would probably not touch this after this because everything in this article is probably going to be here. So it is best to just read it on screen, and then you might want to print these notes. These notes are more important than the article because the notes contain the breakdown information of the main topic. And then these have vocabulary words technically, so you're going to study with these words. Alright, so kinetic energy. Well, kinetic energy is the energy of motion. That was pretty simple. So, let's say, let's just take this here, and we'll say kinetic energy. So we'll just say any object in motion. Any object in motion has kinetic energy. Alright, so now let's just going to move on to mechanical energy. So, mechanical energy of a sort is a mixture of kinetic and potential energy. Right here, I'm reading. So, it's the total energy of motion and the position of an object. Alright, so let's just highlight our vocabulary. Alright, so we can just click on the text block, drag it. So, we'll say total. So, it is the total energy of motion, of kinetic and potential, I think. Potential energy of an object. Alright. Now, one benefit of digital is that I can like move this text around. So if I needed more room, shorten the size, it's pretty cool. And you can actually color code for free. Like, you won't need to buy color pens. Or if you don't have a color printer, there's a nice way to just view notes digitally. And by the way, these images on the bottom, just looking at them digitally is a little easier. Like, let's move on to chemical energy. Now you can see that like nothing's in order here technically. I mean, it's a little in order, but chemical energy is not in order. Like, we had potential before kinetic, and that is it. Like, just finding the words. You might read something that was not required, but you actually may gain knowledge. Like, for instance, like when I was reading for potential energy here, I was like trying to find it. I actually read kinetic energy, so now I know where kinetic energy is, and I can increase my speed on this. So, chemical energy. Where in the world is that? There we go. So, chemical energy is basically what you eat, basically. So we'll say basically what you eat. So this is more human friendly, I'll say. It's like more targeted towards you because this is a very friendly definition. And I'm pretty sure if I read this definition, I would remember it on the test. So you should too. Sound energy. Well, apparently, according to the article, let me go ahead and highlight chemical energy since I forgot. There. So, sound energy is basically, yeah. So, sound energy is vibrations. Basically, vibrations. So, vibrations. It's just vibrations. So, so now, it doesn't in the direction just say and give an example for each one, but I want to do these examples and then you can go back and do them on your own. I think that coming up with examples should be your part. And if I remember, I'll post some examples when I upload this. So then light energy, according to this article, we use it every day. So it's basically where vibrations of electricity are positively charged and all that. So we'll just say that light energy is basically light. And then how it's produced, sort of thing. But we're not gonna write that. Light, I think you can remember. Nuclear energy. Well, apparently here comes from the change of a nucleus. So the energy coming from a change of nucleus. So this is more of chemistry. So like the definitions of like electron splitting and stuff like that, that's more of chemistry. So I will cover a little of atoms and stuff like that in this course, but we won't go into full depth. I might think about moving to full depth about it, but in order to understand this article, just knowing this is enough. Nuclear energy, it's basically energy from nucleus of an atom. Nucleus of an atom that is changed. Alright, so I think it's more human friendly. Thermal energy is right here. So like basic thermal energy is here. Well, maybe if you were reading this article, you might have noticed it was up here. So I didn't read this article like right now. I read a couple of hours ago. So I do not remember where everything is. But I wrote this article, so I have an idea where everything is. But still, let's just say you worked on like 4 problems, right? Now after 4 problems, when you come back, like let's just say after a quick snack, just reread the article, like skim through it again, just to have a fresh idea of the article. So thermal energy is the kinetic energy due to random motion of the particles that make up an object. Right. So this is gonna be very difficult for you to know if you don't know any. We won't know about heat. So heat is a unit we'll be talking about. It will be soon after this. So for now, basically thermal energy, you can actually just describe it as like so if we know our 3 properties of matter, so we'll just say property. It's basically the 3 properties of matter related, like how things heat up. It's related to that, but not fully. Alright, so let's just identify the type of each based on the image. So apparently this selected for me. So this is going to be apparently, it could be light energy or thermal energy. So we'll just describe it as both for now. Because this does fit the properties for both. It does give out thermal energy and it does give out light energy. But mainly it's a light source. So I'll just come back and just highlight it. Apparently can't bold with the shortcut. But if I bold, nope, I can't. So let's just not bold. Or leave it the way it is. Alright. This is definitely sound energy. Alright, so there's one thing let me tell you about this stuff. So just by this, well, this may be producing thermal and light energy. But some objects will be producing more than one. But what is the main purpose of that? So that's what we're kind of looking here. This is probably kinetic energy because of motion. So this does show motion occurring. This is potential energy. And why? Well, pressure is stored here. So this thing does have a potential like length or height. So when this thing is released, it gives off the energy. So this is potential energy. Alright, this is thermal energy because of the fire. So I did not write this in directions, but you cannot use more than one, apparently. So this is light energy. This is a radiation symbol, and that's nuclear power plants. And nuclear energy is generated from nuclear power plants. And it has radiation, so this is nuclear energy. Now, even if you didn't know this, it will be, like, if you didn't know about that it was nuclear energy, I think some people might recognize it. Alright, so we have a test question like here. Let me just zoom in a bit, since we won't probably need the article. So, what type of energy is dealing with an object above the ground, and explain why? Alright, so we know that we're talking about height here. So, if I can get the highlighter work. There. So, above the ground. Alright. So, it's a type of energy. Type energy above the ground, and we have to explain it. Alright. So let's just go through our choices here. Kinetic energy because in order. Alright, so this is talking about kinetic. So it's talking about a motion. It must be above the ground, otherwise it cannot get any motion. This is a distractor. Total distractor. So I was going to make it red. Pinkish. This is once again kinetic energy. We're not talking about kinetic energy here. Potential energy, because in order to have an object to have potential energy, it must have a height and be above the ground surface. Alright, so we got the right energy and the right description. Now this was a pretty easy question, but these are similar answer choices. Like, we might have potential energy, but with one of these definitions. So like, the reason what I'm showing here is A and B were both wrong. Well, apparently if we believe A, let's just say this was potential energy and we just believed it, so we might skip this part. How can it gain motion? So when we skip that, we basically like lost the question point because this is apparently the right definition. So if I just highlight, let me just make this green. So we got it. And then none of the above. So if it was none of the above, you would just put none of the above. No trouble at all. So this is a sample quiz question that you're expecting. There will be an actual quiz and test. So I will have a quiz for lesson 1 out soon, and we will go over the answers in a lecture. So see you in the next lecture.